In this video, we're going to talk about the ideal gas law, as well as go over some ideal gas law problems. So to begin, we're going to break down the ideal gas law equation into its separate parts. So P, the ideal gas law, is expressed as PV equals nRT, where P equals pressure, and that can be in ATM, mmHg, kPa, or in torr. Now, to convert between these four different pressure measurements, we know that 1 ATM is equal to 760 mmHg, which is also equal to 101.3 kPa, which is equal to 760 torr. So you'll see that the torr and the mmHg are both 760, and these are important to know just in case we need to convert from 1 unit to ATM. As a general rule, you always want your pressure in ATM. That way, when you go down and use the gas constant, which we'll talk about in a second, everything will cancel out correctly. So V stands for volume, and that's typically in liters. And for volume, we know that 1 liter equals 1,000 milliliters. The R in the equation is your ideal gas constant. Now, as a gas constant, this will always be the same, so you'll always be given R, either on a formula sheet or in the problem. R is equal to 0.0821 liters times ATM over moles times Kelvin. Going back to when I talked about how we were going to convert pressures typically to ATM, this specific gas constant only works with liters and ATM. So that's why we want to convert our volume to liters and our pressure to ATM. The T in the equation is equal to the temperature, which is expressed in kelvins. Now, to find the temperature in Kelvin, it's pretty similar. We'll take the temperature in degrees Celsius and add 273. By adding 273 to degrees Celsius, that'll give us our temperature in Kelvin. And finally, the N in the equation is equal to the amount of substance. And that's typically expressed in moles. Now that we know more about the PV equals nRT equation, let's go ahead and do some practice problems. So the first problem, they're given the following set of values, and we need to calculate the unknown quantity. So for 1A, we know the pressure, the amount of substance, and the temperature. Now we just need to find the V volume. To define V, we need to take the nRT divided by the pressure. Plugging the numbers that we know into the equation, N is equal to 0.00831 mole. The ideal gas constant, like we said previously, is 0.0821. The temperature is 25 degrees. However, we need to add 273 to it to get it in Kelvin. So 273 plus 25 will give us 298. And we'll divide all that by the pressure, which is 1.01. We can now solve for V. V will equal 0.20 liters. Now for B, we are given the volume, the amount of moles, the temperature in Kelvin. We're trying to find the pressure. So rearranging the equation, we know that pressure is equal to nRT divided by V. So if we plug our numbers in, we have 0.00801 times our gas constant, 0.0821, times our temperature, 311. Now, since this temperature is already in Kelvin, we don't need to add 273 to it, so we're good to just go ahead and plug that into the equation. We'll go ahead and divide this by the volume, which is 0.602 liters. After plugging this into your calculator, you'll find that P is equal to 0.340 atm. Question number 2 says, at what temperature would 2.10 moles of N2 gas have a pressure of 1.25 atm and in a 25-liter tank? So to begin this problem, we'll go ahead and make a list of what we know and what we need to find. So we can tell right off the bat that it says at what temperature, so we don't know the temperature. We are given the moles is equal to 2.1. The pressure is equal to 1.25 atm, and the volume is equal to 25 liters. To solve for T, we need to take nR, or PV, divided by nR. We plug our numbers into the equation. We have 1.25 times 25 divided by 2.10 times 0.0821. After we plug this into our calculator, we'll find that T is equal to 181 Kelvin. The next question is asking, when filling a weather balloon with gas, you have to consider that the gas will expand greatly as it rises and pressure decreases. Let's say that you put about 10 moles, now our N is equal to 10 moles, of HE helium gas into a balloon that can inflate to hold 5,000 liters. Currently, the balloon is not full because of a high pressure on the ground. What is the pressure when the balloon rises to a point where the temperature is negative 10 degrees Celsius and the balloon has completely filled with gas? So we know our temperature is equal to negative 10 degrees Celsius, is equal to 263 degrees Kelvin. We are trying to find the pressure, so we'll put a question mark there to symbolize that we don't know that one. So rearranging the ideal gas law equation, P is equal to nRT over V is equal to n moles times 0.0821 times our temperature, which is 263, divided by our volume, which is 5,000. After plugging this into our equation, we'll find that the pressure is equal to 0.043 atm. The next question is asking what volume is occupied by 5.03 grams of O2 at 25 degrees Celsius and a pressure of 0.998 atm. So we can see that we're trying to find the volume. We know that our N is equal to 5.03 grams, but we need that in moles. So to get that in moles, we need to multiply that by the molar mass of O2, which is 32 grams per mole. And that will equal 0.157 mole. Our temperature is equal to 28 degrees Celsius. We need that in Kelvin, so we'll add 273, and that will give us 301 Kelvin. We know our pressure is equal to 0.998 atm. So now that we have all the variables that we need for this equation, we'll go ahead and plug it in and solve for V. V is equal to nRT divided by P. So V is equal to 0.157 times 0.0821 times 301 Kelvin divided by 0.998 ATM. After we plug this in, we'll find that V is equal to 3.9 liters. The next question says, calculate the pressure in a 212-liter tank containing 23.3 kilograms of argon gas at 25 degrees Celsius. We need to know P. We know N is 23.3 kilograms, but we need that in moles. So 23.3 kilograms times, there's 1,000 grams in 1 kilogram. The molar mass of argon is 39.95 grams per 1 mole. And after we calculate this out, we'll find that the amount of moles is equal to 583.2 moles. We know N is equal to that. Pressure, we don't know. T is going to equal 25 plus 273, which is 298 Kelvin. And V is equal to 212 liters. We plug this into our equation. P is equal to 583.2 times 0.0821 times 298 divided by 212. After solving this on our calculator, we'll find that P is equal to 67.3 liters. Problem number 5 says that an aerosol can contains 400 milliliters of compressed gas at 5.2 atm pressure. When the gas is sprayed into a large plastic bag, the bag inflates to a volume of 2.14 liters. What is the pressure of the gas inside the plastic bag? So to start this one, it's not like the last ones where we're going to be using PV equals nRT. But for this one, we're going to use P1 times V1 equals P2 times V2. So it's saying in this equation that the pressure of 1 times the volume 1 will equal the pressure of 2 times the volume of 2. So we see that the pressure 1 is equal to 5.2 atm. V1 equals 0.400 liters, because it says that there's 400 milliliters, which equals 0.4 liters. And V2 equals 2.14 liters. So we need to arrange this equation to solve for P2. So to get P2 by itself in this equation, we'll go ahead and just move V2 over to the left-hand side. So the final equation will be P2 is equal to P1 times V1 divided by V2. Now that we have the equation rearranged to solve for P2, we'll go ahead and plug the numbers in and solve for it. So P2 will equal P1, which is 5.2 atm, times V1, which is 0.400 liters, divided by V2, which is 2.14 liters. Now you'll see after we go ahead and divide this out that our liters cancel, so we're left with atm. So P2 is equal to 0.972 atm. The final problem we have for this video is number 6, and it says that at what temperature does 16.3 grams of nitrogen gas have a pressure at 1.25 atm in a 25-liter tank? So just like in the previous problems, we're actually going to go ahead and use the PV equals nRT equation here as well. Now, the question gives us the mass of nitrogen gas in grams. So as we know, we need to convert the grams to moles. So we'll go ahead and convert that to moles. 16.3 grams of N2 gas is equal to 28 grams of N2 per mole. And that will give us 0.58 mole. Now we're solving for T, so we need to go ahead and rearrange the ideal gas law equation. To solve for T, we will take T equals PV divided by NR. So we know N equals 0.58 moles. P equals 1.25 atm. V equals 25 liters. And R will equal the ideal gas constant, which is 0.0821. So now to solve for T, all we need to do is plug these numbers into the equation. So T will equal 25 liters times 1.25 atm divided by 0.58 moles times R, which is 0.0821. After putting this in your calculator, you'll find that T equals 654.17 Kelvin. Now remember, the temperature in the ideal gas law equation is in Kelvin. If you're asked to solve this to find the degrees Celsius, we'll just go ahead and subtract 273 Kelvin from this. And that will give us our temperature in degrees Celsius. So the temperature in degrees Celsius will equal 381.02 degrees Celsius. That's all I have for this video. If you found this video helpful, please go ahead and like and subscribe to the channel. I upload new videos every week. Thank you for watching, and I'll see you in the next one. Peace.